right, lesson 10.8, last lesson for chapter 10 before we move into the last chapter. Okay, chapter 10, still factoring and solving quadratics. So we went over all the tools for factoring except using the distributive property. And using the distributive property really is just like looking and factoring out that greatest term from all terms, or the greatest factor from all terms, okay? And that's always, I don't really like the placement of this section because that's always the first thing you want to do, okay? Before you start factoring, try to make it as simple as possible by factoring out anything that's common to all terms. It could just be a number, or it could be a variable, okay? But it has to be common to all terms. So if we look at 33x to the fifth minus 121x squared, okay? We're looking to factor out the greatest common factor, okay? So if I look at 33x to the fifth and I factor that, that's the same as 3 times 11 times x times x times x times x times x. Yeah, because 33 is 3 times 11 and x to the fifth is just x multiplied out 5 times, okay? Then if I look at 121x squared, okay? Well, 121 is 11 times 11, and then x squared is x times x. So we're looking to see if they share anything in their factoring, okay? We're looking for the greatest common factor. So when we look at that, we say, okay, they both have an 11 as a factor. They both have 1x and a second x. Okay, so our greatest common factor is 11x squared. So if I then factor that out, okay, it comes outside a set of parentheses, and then what's inside would be what's left if you divided all of your terms by 11x squared. So if I divide 33x to the fifth by 11x squared, I get 3x cubed. And then it's minus, and then what's left for 121x squared is 11. So I factored by pulling out that greatest common factor. Okay, it's not just a number, but there are variables we can pull out as well to make it simpler for us. Okay, and that's what you're doing first before I try to factor any other way. Okay, so not just numbers, but variables as well. Okay, and we consider a polynomial prime if it's not the product of polynomial integers having integer coefficients. Okay, so to factor it completely, you want to write it as a product of a monomial factor. Okay, that's what this was. This is the 11x squared is a monomial factor. And prime factors with at least 2 terms, okay? So just to see what we mean, if we have 4x squared plus 36, and we write that as factoring out of 4, and then we get x squared plus 9, this would be completely factored, because you cannot factor x squared plus 9. Okay, but if we look at 4x squared minus 36, first I notice I can pull out a 4, and then when I divide both terms by 4, I get x squared minus 9. Okay, 4 is completely factored because it's just a monomial. X squared minus 9, if we think back to factoring, this is the difference of 2 squares. So this is not completely factored. I could rewrite it as 4, x squared minus 9 is a difference of 2 squares, so that's x minus 3 times x plus 3. then this would be completely factored. Okay? So when it says factor completely, it means write it as the smallest products that you can. All right. So we're going to factor 5x squared minus 25, or 5x cubed, sorry, minus 25x squared minus 30x completely, okay? So if we start looking to see if they have any common factors, we look at the numbers first. They all can be divisible or divided by 5. So we're going to pull out a 5, okay? Which means we're really dividing by 5. Then look to see they all have an x. This only has one x, so I can just pull out an x. So my greatest common factor is 5x. So I'm going to divide everything by 5x and then see what's left for what's inside the parentheses. So 5x cubed, pulling out the 5x, what's left is x squared. Then dividing by 5x here, we end up with minus 5x. And then here would be minus 6. Okay? Then we try to factor, okay? You can't factor this greatest common factor, but then we want to see, can you factor x squared minus 5x minus 6? Okay, the leading coefficient of 1, so are there factors of negative 6 that add up to negative 5? And there are. So an x and an x. Factors of negative 6, 1 and 6. You can get negative 5 out of that. So it's a negative 6 and a positive 1. Because negative 6 times 1 is negative 6. And negative 6 plus 1 is negative 5. So it's now completely factored. Okay. Then let's look at 75x to the 4th minus 3x squared. Okay? So first look at their coefficients. Do they have anything in common? Okay, well we can divide them both by 3. So I'm going to pull out a 3. And then this is an x to the 4th and an x squared, so I can pull out an x squared. When you do that, you're dividing by 3x squared. So what's left here is a 25x squared, and then you still need this multiplied by something, so it's minus 1 because we pulled out all of that. Okay? Then we're going to say, can this be factored more? This can be. It's the difference of two squares. That would be 5x squared minus 1 squared. So factoring the difference of two squares, we would get 5x minus 1 times 5x plus 1. And we have factored 75x to the 4th minus 3x squared completely. Okay? So factoring completely means factor anything out that is the same first, so that greatest common factor, and then see the quadratic that's left behind, can you factor it anymore? Okay? All right, very last way to factor is by something called grouping, okay? Because sometimes all those other tools are not going to work. So to factor by grouping, okay, the first thing is you need to have an even number of terms. So 2 terms or 4 terms or 6 terms, we're not going to factor that many terms, so don't worry about that, okay? But for us, we're going to need to do this when you have 4 terms, okay? When you are factoring with 4 terms, you're going to group in groups of 2. So Rx plus Ry plus Sx plus Sy. Okay? So just generalizing it for you. I'm going to put the first 2 terms together and the second 2 terms together. Then what's going to happen is I'm going to say, okay, can I factor anything out of these 2 terms? And they both have an r in common. So I'm going to factor out that r, and I'm left with x plus y. And then here I'm going to factor out the s, and what's left is x plus y. So I've gone from 4 terms now down to 2 terms, because remember the plus sign separates your terms. Okay, so now I have these 2 terms and this term and this term. And I look and I say, okay, do those 2 terms have anything in common? And I see an x plus y. So I factor out x plus y, and I'm left with r plus s. And I've factored by grouping because I've created groups of 2 in order to simplify it for us. Okay, so if I want to factor x to the 3rd plus 4x squared plus 6x plus 24 completely. Okay, I notice that it's an x cubed. They don't all have something in common, so let me try to group them together. I'm going to put these 2 together, and I'm going to put these 2 together. Okay, so in these first 2 terms, do they have something in common? So do they have a greatest common factor? And they do. The greatest common factor is just x squared. So I'm going to factor out an x squared. When I factor out x squared, I'm dividing. So that means I'm left with an x plus 4. Okay? Then I look at these 2 terms. Do they have a common factor? And they do. I'm going to factor out a 6. Okay? So I divide both by 6, and I'm left with x plus 4. Well, look at that. Okay? When I look at these 2 new terms, this is one term, this is another term, okay? I notice they both have an x plus 4 as a factor because it's being multiplied. So I'm going to factor out x plus 4, and then what's left is x squared plus 6. And it's factored, okay? I would have to look. I can't factor x plus 4 because that's a linear binomial. And then x squared plus 6, it's not a difference, so that's as factored as that gets. And I've factored our original expression completely. Okay? All right. Let's do one more. So I have x cubed plus 2x squared minus 36x minus 72. Okay, I want to factor completely. So do it by grouping. I'm going to put these 2 together, and then I'm going to take this negative because I need the sign. So it's going to be plus negative 36x minus 72, grouped that way. Okay, look at these 2 terms. Do they have a common factor? They do. I'm going to factor out an x squared. When I factor out x squared, what's left behind is x cubed, or x plus 2. Right? You divide both terms by x squared to see what's left. So I get x plus 2. I'm going to look at these 2 terms. This one I'm going to factor out a negative 36. When I divide both by 36, I'm left with, or negative 36, I'm left with x plus 2. Okay? Then I need to factor some more because I've got an x plus 2 and an x plus 2. So I pull that out. When I pull out x plus 2, I'm left with x squared minus 36. And then I have to say, am I done factoring? Not quite. Okay, I get x plus 2 and x squared minus 36. So x plus 2 can't be factored anymore because it's a linear binomial. Then I look and I say, oh, this is a difference of 2 squares. X squared minus 6 squared. So I can factor that to x minus 6 times x plus 6. Okay? Now it is completely factored. The last thing you want to be able to do with factoring is to solve your equations. Okay, so solving just puts an equal sign, and you want to get it so 0 is on the other side. Okay, so if I want to solve 16x cubed minus 100x equals 0, that's the first step, if you have something over here, you need to put it all on one side so it's equal to 0. Okay? So the first step is to factor. It says 2 terms, so I'm going to see if they have anything in common. I can factor out a 4 from both of these and an x. Then I'm left with 4x squared minus 25. And I ask myself, is it completely factored? Not quite, because that's the difference of 2 squares. So it's going to be 4x times 2x minus 5 times 2x plus 5. Okay? Then, once it's completely factored, you would use the zero product property. So you would set each term equal to 0. And then solve for x. So 4x equals 0, I'm dividing by 4. I get x equals 0. 2x minus 5 equals 0. So I need to add 5 and then divide by 2. So I get 5 over 2 for x. Here I need to subtract 5 and divide by 2. So I get negative 5 over 2 for x there. Okay, so added step, factor out common factors, and then if you're solving, make sure it's equal to 0 and use the zero product property. Okay, so that finishes chapter 10. Make sure you're looking for your chapter 10 test due, I think we go on spring break, so due after spring break.